Welcome to episode 210 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm all right, Rob. How you doing?
I'm doing okay, aside from fighting with the CppCast website all week.
Yes. So if you're following along on Twitter, the website went boom.
Yes, it died spectacularly. Although if you go and navigate to it, it's still there. It's just out of date by a week and a half. It still shows a recent episode with Claire McRae about approval tests. Does not show Matt Butler's episode on secure coding yet, but hopefully I'm going to fix that this week. And by the time you're listening to this, the new website will be up.
That'd be great.
Yeah.
And I just realized within the next month, am giving 4 talks at 2 conferences and teaching 3 classes.
That's very busy, Jason.
That's a busy month, yes.
Yeah.
I'm looking forward to October, basically.
Yeah, I would be too. Okay. Well, the top episode, I'd like to read a piece of feedback. And if you're following on Twitter, you saw that I put out a request for suggestions for a good alternative static site generator. We were previously using DocPad, which is a JavaScript-based static site generator that is apparently horribly out of date. The maintainer of it says it hasn't been supported for like 3 years. So we got a couple of recommendations for Hugo as well as some other generators, and I'm going with Hugo because we had Corentin Jabot, recommended it. We had on recently, as well as a couple other people on Twitter.
I like this one recommendation of Wikipedia.
Yeah, I don't think that's going to work.
Although, I mean, the Wikipedia, what is it called? Like, it's still, I assume it's still an open source backend. Anyone can just make a wiki. It would be an idea, but no.
Idea. Yeah, so we're going with Hugo, and hopefully I'll have that new site with Hugo up this week.
Looking forward to it.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes and subscribe on YouTube. Joining us today is Bryce Adelstein Lelbach. Bryce has spent nearly a decade developing libraries in C++. Bryce is passionate about C++ evolution and is one of the leaders of the C++ community. He's an officer of ISO, IEC, JTC1, SE22, WGD21, the C++ Standards Committee. Bryce chairs both the C++ Committee's Tooling Study Group and Library Evolution Incubator. He is the program chair for the C++ Now and CppCon conferences and the chief organizer of the Bay Area C++ user group. On the C++ Committee, he has personally worked on the C++ 17 parallel algorithms, executors, futures, senders, receivers, multi-dimensional arrays, and modules. Bryce works at NVIDIA, where he leads the CUDA C++ core libraries team. He's one of the initial developers of the HPX parallel runtime system, and he's also helped start the LLVM Linux initiative and has occasionally contributed to the Boost C++ libraries. Bryce, welcome back to the show.
It's good to be here. That is quite a mouthful. I'm impressed.
Yeah, your bio has gotten longer since we last had you on.
As Rob's reading along, I'm like, does he actually work anywhere right now? Because
it's funny. People seem to ask me that a lot because I think I've spent about half of this year in the office and about half of this year at conferences or committee meetings.
And your employer expects this.
Yes, my employer expects this. Yeah.
Okay.
They care about what we get done, not necessarily when we're there. But for NVIDIA, supporting the C++ language is very important. It's a bigger picture, like, strategic goal for us. So we really care about the C++ community, and that's why we have so many people from NVIDIA that go to C++ committee meetings and conferences. And we actually, I think we're the only organization that has people chairing 3 different groups of the standards. It's subgroups of the standard committee.
Like Google, Microsoft, they get a lot of the press for having involvement in the committee, but it's great to hear that NVIDIA invests that much in it as well.
Yeah.
Okay. Well, Bryce, we got a couple of news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about your recent work with the committee.
All righty.
Okay. So this first one, we have an update from resharper C++ from JetBrains. And this one is 2019.2, faster indexing, improved C++20 support, and better Unreal Engine support. And yeah, I mean, it's always great to see them keeping up with the standard and improving resharper C++. I'm definitely a user, so I'm looking forward to grabbing this new update.
Yeah, it's interesting timing for me because I was doing some research for one of my talks and I installed resharper just to help with some like refactoring tools and stuff.
Mm-hmm.
It's the first time I installed it in a couple of years, and I'm getting these, pop-ups from Visual Studio. Resharper's plugin has taken 6 seconds of unresponsiveness, and it's a large, complicated project. So I'm like, oh, well, look, a new release was out literally like 5 days after I installed the one that I had, and to see it's got, performance improvements, that seems immediately welcome.
Yeah. I think Visual Studio will let you know about any plugin that's being a little slow, but it's,
Yeah,
I never really
just
noticed
resharper
it.
thing.
Yeah.
I think it's pretty exciting because they've already started adding support for C++20 features in this release, including features that were like just added to the standard at the last meeting.
Yeah, so the new char8t type is in, conditional explicit. Yeah, plenty of new C++20 features.
Yeah, const eval, constant.
Yeah.
And I was just, it's not directly related. I mean, they did a bunch of code analysis updates as well, and I was impressed the last time I installed it just how much the code analysis kinds of things that it does, where it's telling you this variable should be const or whatever.
Right.
So it's always, I mean, everyone knows I'm a huge fan of tools. It's great to see even more things coming, improvements.
I mean, speaking of performance, I think down the road, tools like resharper will really be able to benefit from modules. It's just potentially quite a big task for them to integrate modules into their tool. I mean, it's a very different way of browsing through your source code, but modules should allow them to only load the entities that they need from a particular translation unit instead of having to parse through everything.
Right.
So it's a very exciting future for tools in our new modular world.
I'm kind of curious if our compiler vendors do a good job of publishing their module specs, how much that'll help tool vendors too, if they can just directly parse like the module output.
That's one of the reasons why we are creating this C++ modules ecosystem technical report out of the tooling study group is to give the implementers a place where they can come together and agree upon things, and give tooling vendors a resource that they can use to figure out how to integrate with modules and with particular implementations of modules.
Okay. This next one we have is from the Visual C++ blog, and this is game performance improvements in Visual Studio 2019 16.2. And they're going over a bunch of optimizations and actually showing some assembly output in some of the changes they're putting in. This first one showing vectorizing tiny perfect reduction loops. And then, they're showing how it goes to a fairly large block of assembly down to just like 5 lines of assembly. So definitely showing some good performance improvements here.
Also looks like they're doing some better job of constant folding, which I'm always a huge fan of. If the compiler can just make the code go away altogether, that's better.
Yeah.
Although, can we all agree that the first example should probably be replaced with a std reduce or a std transform reduce? And that's the real optimization we want here.
Gotta Sean Parentify that code.
That is a good point. I didn't see it immediately. I try to be familiar with the algorithms, but there's a lot of them.
Yeah.
Yes, there are a lot of them, yes.
There's one other thing that stood out to me on this, and it's been kind of like itching in the back of my brain here, is this arc AVX2, that's great, /O2, that is all optimizations in Visual Studio, that's great, and then FP:/fast. Wait a minute. Floating point fast math? I'm pretty sure I've heard Clang developers say that should never be used because do you want accurate results or not is the answer there. Is that also true in Visual Studio, or am I overthinking this?
Well, so that's sort of a matter of opinion. I mean, a lot of people in the scientific computing world will use fast math, but then there's a lot of people in the scientific computing world who won't use fast math because the loss of accuracy guarantees is not acceptable for them. But I think it really just depends on what you're optimizing for. Are you willing to sacrifice some fidelity for speed?
Yeah,
So
if
in the
games
games
about visuals or about game performance, then I could definitely see them going with fast math.
Yeah.
Yeah. I actually had a class of a largely physicist in my last class, and I was having some brief discussion with them how some game developers describe game programming as like physics simulations, but at real time.
Yeah.
They throw away however much accuracy they can to get something that looks good.
Yeah, but of course, if you're simulating something that is going to be mission critical, and you want to make sure that it's accurate, 100% accurate, that's a very different type of physics simulation than a game where you just need it to look good enough.
Right.
And then this last article we have is about Cosmos Scout VR. Jason, you want to tell us more about this one?
Yeah, I mean, it got a lot of basically attention on Reddit here, so I thought it was worth mentioning. But the German Center for what is it?
Something?
Yes, German Aerospace Center.
Yeah.
There we go. Has released their like VR tool for browsing through our planetary bodies and doing simulations of planetary bodies, celestial bodies, and stuff. And it's open source and at least relatively modern C++, and it looked interesting. I don't personally have any way of viewing VR things. Does anyone here have?
I do not either. And I'm wondering, is it VR required? Like, could you just run this on your desktop or laptop without having any VR equipment, or does it really require VR? Hey, no, it says interaction works both in VR and on desktop, so you could try it with VR.
Do you have since you work for NVIDIA, have like a room full of VR gear, Bryce?
I have a lot of VR capable GPUs at my desk. I have somewhere in the range of 20 GPUs at my desk. I don't actually have any VR equipment, but there's a bunch of people who sit in the general region that I'm in that have all sorts of cool VR stuff.
So you're like at your desk at work, and you're like, "Oh, someone comes by. Do you have an extra, whatever high-end video card?" And you're like, "Well, I think I've got a spare one around here somewhere." And you just like,
I'm very organized about it. Each one of them is labeled in 3 places and has my name on it, and there's a sign-out sheet because otherwise stuff never comes back.
That's just easy to believe. It's like loaning a neighbor your tools.
Exactly.
Very cool. Okay, well, Bryce, we actually got this email from a listener recently asking us to have someone on to talk about mdspan, which is a proposal to add a multi-dimensional array to C++, and I saw that you were one of the authors on this paper, so could you start off by maybe just telling us a little bit about what mdspan is?
And in fact, mdspan is the first paper I was ever involved in on the committee, and in some ways was why I joined the committee.
Oh, interesting.
So mdspan is it's a multi-dimensional version of span. So if you know what span or string view is, then you have an idea of what the basic properties of mdspan is. That is, it is a non-owning reference or view type. So string view is a non-owning view type that cannot modify its underlying elements. That's not what mdspan is. mdspan is more like span, where it's some view into some type of container, and it can modify the underlying elements. Conceptually, you can think of it as, like, if you think of span conceptually as being a pointer plus a size, then mdspan is conceptually a pointer plus a set of sizes, or or what we call a layout, some way of indexing into some contiguous or potentially non-contiguous range of storage. So one of the key design goals of mdspan was to give us a type that parameterized the layout. So for example, if you were switching from column major to row major layout, you would not need to change how your code that uses an mdspan is written. You would just change the layout parameter of mdspan. Whereas if you're writing just a raw indexing code for row major versus column major, you have to go and change all of your loops if you want to switch between different layouts. So one of the goals here is to give us a type that we can easily swap out the underlying layout of the multidimensional structure, which sometimes you want to do for performance reasons, sometimes you want to do for interoperability reasons. And that's sort of another aspect of mdspan, is that it's not its own owning container type. It's meant to be something that is an abstraction that references some storage that you, the user, owns. So if you have some matrix type, you can construct an mdspan that points to your matrix type, in the same way that you can use string view to create a reference to your own internal in-house string type. So it's something that we've been looking at standardizing for a number of years. It's sort of this very fundamental type for high-performance computing, linear algebra, geometry, 2D graphics. And over the years, there have been an increasing number of people who have looked at this and said, oh, hey, this would be useful for my domain. So I think once we standardize it, it will end up proving to be one of the sort of fundamental vocabulary types of the standard library.
Go ahead, Jason.
I was just going to say, so what is the progress on trying to get it standardized?
So there was originally an effort to sort of unify span and mdspan. So the original span proposal was a multi-dimensional span proposal, but it was not designed in such a way that was suitable for high performance computing, and so we eventually ended up deciding in the C++20 timeframe to separate out the one-dimensional type span from the multi-dimensional type, because we had a lot more what we call in the committee field experience with the one-dimensional span than we had with the multi-dimensional span. So we went from having just one sort of megatype to having span, which has gone into C++20, and mdspan, which I believe is currently targeted to go into the next library fundamentals technical specification right now. And so because of that, work on it has been a little bit on the back burner for the past year because we've been focusing on C++20 stuff. Now, if you want my opinion, I think it's more likely that we put this into C++23 or C++26. And if you want even more of my opinion, I'm not a huge fan of the library fundamentals technical specifications. I just don't think they're focused enough. So I think we'll probably get this in C++23, or we'll get it in a TS in the 23 timeframe, and then in the standard in 26.
So you mentioned span several times, but I want to be clear. Does it require a contiguous layout like span does?
No, it does not.
Okay.
It fundamentally has one base pointer though, but it might not index into a contiguous region. Like it might represent like a slice of some region. You can't give it multiple base pointers, but it's not necessarily the case that all the elements are contiguous within the storage region. But they are.
So it has one base pointer.
Yeah.
And okay, but if I'm just trying to visualize this. So it's like a subrectangle inside of a larger rectangle. Not all of those points are contiguous relative to each other, but the overall block of memory is contiguous.
Right. And you can think about even weirder layouts, like sparse layouts, where the distance between different elements might not even be fixed or predictable.
How would that work?
The way that you would implement that is pretty simple. You know, you have to have some sort of you have to have more storage for your layout, Like typically your layout storage is just like the extents of things, like how large is each one of these dimensions, how large are my strides, etc. If you wanted to have some sort of sparse layout, you probably need more information than that. And also your indexing operations are probably a bit more expensive. They're not just some simple integer math. Right. But mdspan is designed to be general purpose enough that you could express a more complex layout like that. Or a better example might be something like a triangular layout, which is not necessarily arbitrary, but doesn't have a constant stride between the different elements. But doesn't necessarily require dynamic storage for the position of each one of those elements.
Okay.
Okay. Why is this particular proposal been in process for so long? It looks like it was first proposed back in like 2015. I mean, it sounds like the scientific community, has a lot of experience with this. Why has it been in the works for so long?
Because it's a big feature. So it's somewhat small in terms of its interface surface, but there is to get this right, it really, like, this is a generic interface, and to get this right, we had to put a lot of thought into just what that generic interface looked like. For example, one of the more recent additions to mdspan, the original proposals for mdspan had a variadic set of properties. Properties could be things like, how is the memory accessed? Like, is it accessed through a cache bypass, or is it accessed atomically, or other properties like that? And this was intended to be an open set of properties that could be extended by vendors. In more recent revisions of this proposal, we replaced that mechanism because, generally speaking, open extensible property mechanisms in the standard don't have a great track record. So we instead replaced that with an idea of mine, which is this notion of an accessor. So an accessor is an object that abstracts away the accessing of a pointer. So if you have an accessor object, you give it a pointer and an index into that pointer, and then the accessor just goes in like in the simple case, just accesses the element at that index. But then having it be an abstraction means that you can, if you want to customize how memory is actually accessed, you can write your own accessor that does whatever weird thing you want and plug it into mdspan. So just like a little detail like that is something that evolved later in this proposal's life, but made it a significantly better proposal because there's, as I mentioned at the start, there's a ton of different people who want to be able to use this thing, so it's really important that we make it extensible enough for everybody to be able to use it.
Great.
Okay.
And one of the comments that I saw come up was there's no great way to make a two-dimensional array in C++ today. Like,
right.
We want an array of arrays, vector of vectors. Vector vectors is probably a bad idea, that kind of thing. So it sounds like, if I'm hearing you right, like maybe I would just create a standard array and then use an mdspan to say, treat this like a three-dimensional container.
Yes, or you could use an MD array, which is another proposal that is, MD array is essentially a container adapter that is built with an mdspan and some underlying thing. So it's mdspan is sort of this lower level facility that's this not only view type, but if you just want like an array type, we're planning on adding something to the standard that builds on top of this that's a more user-friendly version of this.
Planning to. So does that in the same state as mdspan right now, or is it lagging?
I believe that paper first showed up at the last meeting. One of the reasons it was written was because the linear algebra proposals are planning on using mdspan. And so the MD array proposal was written as a part of the linear algebra effort. And I believe that it was seen by Lug, and I'm basing that assumption on the fact that it was an R0 paper that I didn't see in Lugi. So that makes me assume that it was on the Lug agenda, and that's why it wasn't on my agenda.
Sorry, you now have to take a moment just for listeners who aren't familiar. Lug and Loogie, it just sounds like you're making up words.
Loogie is the Library Evolution Working Group Incubator, which is the first. It is a study group that looks at early standard library proposals and gives them feedback and directional guidance before they go on to the primary library evolution group. So typically, I chair that group. Typically, that group sees all new proposals that add standard library features before they go to the library evolution group. But sometimes maybe 30 or 40% of proposals just go directly to the main library evolution group, just depending on their priority and the amount of time that we have.
So I'm sorry now then, who did you say is currently looking at the MD array?
I believe that it was seen by the main library evolution group at Cologne. I don't know what the state of it is.
Right.
Although that is quick enough, easy enough for one to check.
And this is, while you're looking that up, to make sure I have my history right, this linear algebra is fork's not the right word, it's a branch of the work that was done in the 2D graphics proposal with our friend Guy Davidson, who's been on a couple times.
There are currently 2 linear algebra proposals. There is that one proposal, which is just what you described, and then there is an industry and HPC-driven proposal, which I don't have the number for, but it is essentially a proposal for a linear algebra library based on BLAS, which is the basic linear algebra subprograms, which is the standard linear algebra library available on pretty much every platform, although it can be a bit of a pain to actually use it in C++ because it is primarily has a Fortran interface. So that is a separate linear algebra proposal that's sort of targeting a lower layer in the stack. We would presumably build the linear algebra proposal that Guy and Bob are working on top of that lower level facility.
Okay.
The MD array paper is 1684, and yes, it was in fact seen by Lug, and they want to see a revision of the paper, according to the notes that I have in front of me.
Okay.
Well, since you brought up Cologne, we have been talking about Cologne a little bit over the past few weeks. We had Botan Bala and Tom Honnerman do a trip report with us, and that trip report was based in a large part on us going over your excellent trip report that you posted to Reddit. Was there anything that you wanted to go over that you worked on personally that we maybe haven't discussed already?
Well, I should first note that those trip reports, while excellent, are not just me. In fact, we crowdsourced it out to a very large team. There's approximately 30 to 40 people who are involved in writing those trip reports. We have a Google Doc that gets created either the night before or traditionally the morning of the closing plenary, and we just all fill it in. So I can't take all the credit, sadly.
But you get all the Reddit gold for it.
I do get all the Reddit gold for it. Yes, that's why I do it, for the Reddit gold. And in fact,
whatever that even means.
At Cologne, I had a train leaving Cologne at 12:42 to go to Paris for my birthday. And I was getting worried because the closing session of the committee meeting, it was like around 11:30 and we weren't over yet. But I couldn't leave because I needed to be there to post the Reddit trip report the moment that we closed for the week, because that's what we do, is we post it as soon as we're officially over. So I waited until like 12:10, and that's when we actually finished up, and I pressed the send button, and then I very rapidly left the room and ran to my train.
Is it then the hotel was close enough to the train station that was doable?
Yes, I made it there with a little bit of time to spare even. So did you guys talk about modules when you did your Cologne trip report?
Modules have come up many times. They were approved, right? I mean,
yeah.
So I think one of the more interesting things for me that happened at the Clone meeting is we had a full day meeting of the tooling study group, which I chair, and during the Clone meeting, the evolution working group approved the start of work on a C++ modules ecosystem technical report, which will be a formal ISO document that is a separate document from the standard, and that document will record and describe the best practices for using modules, and also describe some details of modules and module implementations that we just can't specify in the standard. Things like formats for dependency metadata, how what different module build modes are, how they work, how things like fast dependency scanners work, sort of all of the details of stuff that's really more details of the tooling and the build ecosystem than the actual structure of C++ source code itself. And so we made a lot of progress on this technical report, and we've made a lot of progress on getting all of the various stakeholders unified over the past couple of months, and we had a very productive session at Cologne. One of the outcomes of that session at Cologne is that we've determined that we do not want to pursue specifying a specific project structure or file naming convention in this technical report, but we do care a lot about making sure that implicit module builds work well. And for that to be the case, that essentially mandates that what we care about is seeing fast dependency scanners be developed. Because if you're not going to enforce a particular project structure or file naming structure or module naming structure, and you want to just magically be able to build C++ projects that use modules without any explicit mapping describing like what those modules are and the dependencies between them, well, then you need some sort of magical tool that can quickly scan over your project and determine those dependencies. And it better be able to do that pretty quickly. And so we had consensus at the meeting that we are interested in that. We do care about implicit module builds, and because we don't want to specify a specific structure, that means that we just care about fast dependency scanners. So that was something that I think I did not, we as a group did not fully realize that we felt that way prior to the meeting. And it's good that we now have a clear direction for that'll really help us focus what goes into the modules ecosystem technical report. And we made some progress on a few other things. Richard Smith had a paper P1767 called Packaging Modules, although the name is a little misleading. It's really more about build system interchange. It proposes sort of a formal framework for thinking about how different package systems and build systems should exchange information about modular C++ projects. And I think it's a very important paper. If you care about packaging and modular builds, you should probably take a look at that paper. It's going to sort of be the basis of our thinking on module packaging and build system interchange interactions.
That does sound like really significant because, I mean, I don't know, but I don't think there's anything else that currently recommends a way for compilers and tools to talk to each other, right? I mean, that's unprecedented.
That is correct. It is unprecedented. Yes. Okay. And that's one of the reasons why I think this work that we're doing in the tooling study group is going to be very significant going forward. If we can be successful in specifying some points of interoperability, like some of these formats that all the compilers will speak for build system interchange and dependency metadata. We might have a lot less implementation divergence in the details of how modules work between all the major implementations. And I think there could also be impacts for other languages and for like the broader ecosystem, especially if we do end up settling on some build system interchange format. Essentially, we're talking about something that I think roughly amounts to a suggested, like something like package config. I don't want to say a standardized version of package config because it's not something that would be in the C++ standard. It would just be in this technical report, right. But that.
So that's packages, where to find them, modules, hypothetically. Would it go so far as to like what's in the modules? Like, would we get anything like a standardized or at least a recommended name mangling convention?
That I think is pretty unlikely to happen, and one of the reasons is that modules support two different ownership models. Okay. There's what's called strong module ownership, where entities that are within a module always have that module's name as part of their mangled name, even entities with external linkage. And then the weak ownership model, only entities with module linkage, so only entities that are visible only within a module, have the module name as part of their ABI, as part of their mangled name. And different implementations want to pick different models. So Clang and GCC are planning to go with a weak ownership model, and MSVC is planning on going with a strong ownership model. The implication here is, of course, can you move entities that are exported from a module to another module without an ABI break, without changing how that entity is mangled? In the strong ownership model, it is an ABI break to move an exported entity between two different modules. And in the weak ownership model, it's not an ABI break.
It's a tongue twister. Say module model 5 times fast.
Yes. And there's questions about like a standardized representation of compiled modules. I think is almost certainly something that would never happen. In Clang and LLVM, for example, the compiled module representation is literally like a serialized version of the Clang AST. It is super subject to change. Like between different revisions of Clang, that representation might change. I believe Microsoft's representation is intended to be a little bit more stable. I'm not sure about GCC's. I think it falls more in the line of what Clang and LLVM are doing. And each one of those implementations has different user bases and different design constraints. So I don't think that right now that there's any chance that we'll have some sort of standardized compiled module representation.
Okay.
Is this report on modules going to come out at the same time that the C++20 draft is finalized?
The report is feature-driven, not deadline-driven. It will come out when it is ready. For it to be useful, we need to get sufficient field experience with modules. I think 6 months ago, we didn't really have, we had 1.5 implementations. Now we have 3 fairly solid alpha or beta implementations of C++20 modules, and they're all maturing fairly rapidly. I think we probably have at least another year to 18 months before the technical report comes out for us to be able to get all the content for it and for us to get enough field experience with it to inform the technical report. But one of the things about the technical report is it's intended to be a report. It's intended to be backed up by data and to have conclusions that draw upon that data.
Okay. So we start off that discussion on modules by talking about the C++ Reddit trip report. And as we mentioned, you're one of the moderators of the C++ subreddit. Do you want to tell us more about your role as moderator there?
Sure. So I became a moderator of RCPP, I think in 2015 or 2016. I actually just asked to become a moderator. There was a particular flame war that happened on the subreddit, and I had calmed things down a little bit, and I just suggested to the mods hey, I think we could use some more moderators. Why don't y'all make me a moderator? And that worked out. So I've been doing it for 2 or 3 years now. There's about 5 or 6 other moderators, about 3 to 4 of us who are particularly active. STL, Stefan, who is one of the main maintainers of the Microsoft standard library, is one of the moderators. There's a fellow who I don't actually know his name in the real world, and if he's listening to this, I will apologize to him later. But his handle is CLEROTH, I think. And he's a game developer. He's been a moderator. He got made a moderator around the same time I was. The biggest thing that we probably do is deal with off-topic posts. So there's a billion giant warning signs on the Reddit and on the submission page that say, please don't submit homework questions.
Right.
But we get about 3 or 4 homework questions a day. So we try to clear those out because our CPP it's really intended to be a place for C++, professional C++ developers, enthusiast C++ developers, anybody who's interested in C++ to come and talk about the latest developments in C++ evolution, C++ libraries, the C++ community. It's not intended to be a place to come to get, help on your C++ problems.
It's not Stack Overflow.
Right, it's not Stack Overflow. And there is a separate subreddit, our CPP questions for that. That's not to say that asking a question in our CPP is always off topic. For example, if you write a post that asks a very deep question about C++, or even a not so deep question, but just you have a very thoughtful post and there's stuff there to discuss, that's completely fine. It is, at the end of the day, a discussion format. So it's fine for you to ask a question if your question is going to spur discussion. But if you're just saying, hey, I had this compiler error, can you help me fix it? We're not the place for that. There's also the actual moderation part of the job. So there are times when the subreddit can get a little heated. And so we have to keep an eye out for that and try to encourage people to be civil. I'd say I think that there's room for improvement in sort of the culture of the subreddit. We could do a little bit better job of being welcoming to people. But I think we've come a long way since when I first started using RCPP. And I think generally speaking, discussions on RCPP are pretty thoughtful and fairly technical. One of the things that we look for as moderators is when does a discussion stop being a technical disagreement and start becoming a personal disagreement, and that's when it's time for it to not be happening on my subreddit.
Your subreddit.
I say that as a parent to a child, and I'm sure I will get flack on Twitter for that comment.
Are there any other online C++ communities that you're involved with, moderate or anything?
Yes, I am one of the admins for the CPP Lang Slack. I will say I am not super active there, which is actually a good public service announcement. If you see something on the C++ language Slack that you believe needs moderation, it's good to call it out or to notify a mod or to use the @mods handle, because there's a lot of stuff that gets said on that Slack. Like Reddit, there's maybe 10 or 20 posts a day. I can just look at all of those. I can't be in every room on Slack. I can't keep track of all of that. So I think it's much more difficult to moderate a Slack instance than it is to moderate Reddit. Yeah. But
I just pulled it up just out of curiosity.
Yeah.
There's currently 13,000 people in general.
Yeah.
Oh, wow.
Yeah. And yeah, those are the two like places where I'm some sort of moderator. And I'm also active on the Include C++ Discord channel and Twitter, of course. I'm on the tweets a lot.
That you don't moderate, though.
That I do not moderate. No.
Be
a shame there's no one to moderate Twitter.
Every now and then it would be handy.
Yeah. Yes. It certainly would be. Yeah.
So you mentioned in your bio you're also program chair for CppCon and C++ Now. C++ Now effectively just ended as far as the timeline of C++ events over the year ago, and CppCon is starting very soon.
Yes, I have to go finish implementing all the code for my talk. That's a little scary.
So what talk are you giving?
I'm giving a talk about the C++20 synchronization library, which is a combination of various new synchronization and communication primitives and enhancements to old synchronization primitives, all of which is landing in C++20. So the atomic wait and notify API, semaphore types, barriers, latches, floating point atomics, atomic ref. I'm sure I'm forgetting one or two things.
Someone will point them out during the talk.
Yeah. So I think I have a cool idea for how I'm going to do the talk. Originally, I was going to try to do the talk as, a couple different examples for each thing, but now I'm thinking I can build a little mini like tasking runtime, and that I can use. I would actually need all of those facilities I just mentioned at some point in that project. So I'm thinking I'll maybe just do the talk as one big long example.
That sounds great.
Yeah.
I will come and see whether or not you succeed at that.
Yeah.
Actually, I can't promise that because I haven't looked at the schedule at all. But it does sound like a great idea.
I hope it proves to be one. Yeah.
Anything else you're looking forward to with CppCon this year or at the new location?
So, I think this is going to be a very exciting year for us. We have a particularly strong program. This is the first year when making the final programming decisions was really, truly agonizing torture. It's usually painful, but this year it was very difficult to make those final decisions. We had to say no to a lot of good talks because we just had that many good talks. So I think we have a very strong program this year. I'm glad that the number of submissions we get every year continues to increase, because that helps us make a better program. When we're making difficult decisions, that's how I know we have a good program.
Right.
I think we've got a lot of really good C++20 content showing up this year, and yeah, I think just in general it's a strong program. We have a lot more talks from the like low latency and financial world than we've had in past years. I've always wanted to have some more of that. Trying to think of other particularly. We of course we always have really good concurrency and parallelism talks. That's true this year too. And yeah, it's a good program. I would encourage people to come and attend. It's a new venue. It should be super exciting. I'm really looking forward to it.
It looks like we've got upwards to 8 tracks, depending on the particular time slot.
Yes, that is correct. This started out as like a 5-track conference, and then it became a 6-track conference, then it became a 6.5-track conference, then a 7-track conference. Now we're basically up to 8 tracks. And one of the reasons for that is that we've added a track that I should have mentioned, but thank you for reminding me, called Back to Basics.
Yes.
And the Back to Basics track is essentially it's talks on sort of fundamental C++ subjects or just like basic C++ knowledge, stuff that many CppCon attendees might know. But we wanted to have this track because there are a lot of people who come to CppCon who are not, senior C++, who aren't, your senior C++ programmer with 10 to 15 years of experience. But I also think it's the case that even if you are very experienced, I'd still encourage you to check out this track because I think a lot of those basics have either changed since you learned them, or there's some like detail of them that you may have never known. So I'm very excited for it. I think in our first year at CppCon, people didn't know where to target talks. People thought, oh, we need talks to be really, really, really basic for the masses. And we got a lot of feedback on talks that first year, which was basically this stuff is too basic. And I think that we might have course corrected a little bit too hard, that we veered away from fundamentals talks a little bit after the first year. And now we've really had over the years a lot of really great talks, but talks on intermediate to advanced subjects. We have not had a lot of talks on beginner material. And I think the return of that content will be good for the conference and good for people who are watching on YouTube.
Cool.
Okay. Well, is there anything else you wanted to go over today before we let you go, Bryce?
That's it. That's all I can think of.
Okay. Well, it's been great having you on the show again today.
It's been great being here.
Thanks for coming on.